Hello everyone, welcome to Josh Max channel. In this video, we are going to see for CBSE Maths Grade 12 Standard Chapter 5 Continuity and Differentiability in Exercise 5.1 30-second sum. Already in the last videos, I have uploaded till 31st sum solution. So please do check it. Now let's start with the 30-second sum. Show that the function defined by f of x equal to modulus of cos x is a continuous function. So here they're asking us to prove that the given f of x is continuous for all the real values, because here the indicated point is not given. So we need to prove that f of x is continuous for all the real values. But one thing, if you notice, here f of x is what? Modulus of cos x, no? This is combination of two different functions. First, I will explain how it is combination of two different functions. Then we can move on to the solution part of the 30-second sum. Okay. So now I'm going to consider g of x as a modulus of x. Okay. And h of x is as a cos x. So the composition function. So g of h is, this can be rewritten in the form of g of h of x. So what is the h of x here? Cos x, g of cos x. G of x is modulus of x, no? So what is the meaning of this? If input is x, it coming as a output as a modulus function. So here input is cos x, then we have to write this as a modulus of cos x. So what we can say from this? So modulus of cos x is the combination of g of x and h of x, right? Okay. So this is our f of x. So we have one property in the continuous, that when two continuous functions are combined, okay, the combination of two continuous functions also continuous. So we are going to say individually that g of x is a continuous, and we are going to prove that part, and h of x, that is cos x, is a continuous, that we are going to prove. Then we are going to say that since g of x and h of x is continuous, then g of h of x is also continuous. G of h of x is what? F of x is continuous. So this is how we are going to do this sum. Okay. So now let me prove that g of x is a modulus of x is a continuous function. Okay. So we have g of x is what? Modulus of x. Now a modulus function, what we have to do, we need to redefine that function first. So g of x equal to minus x and x. And here when we have to use the minus x, if x is less than 0. And the second function x we have to use if x is greater than or equal to 0. Now using the if condition, if we break the real line, okay, we can able to get here one interval, here one interval, and at x equal to 0. That means to check the continuity for the g of x, we have three cases here. Okay, throughout the real line we have to check. So in the case 1, at x equal to 0, we have to prove the function is continuous. That means f of 0, left hand limit, right hand limit, all the three things are required. Now if x is less than 0, in this interval function is continuous, we have to prove. Then if x is greater than 0, function is continuous. So totally three cases we have for this sum. Now case 1. What is the case 1? I can, any order is fine. At x equal to 0, I am going to consider if x is exactly 0. Okay, to prove the continuity, what are the things are required? We need f of 0, left hand limit, and right hand limit. Now let's find out what is f of 0. When x takes the exactly 0, what is a suitable function here? X, no? G of x equal to x, then g of 0 will be, sorry, this is g. So g of 0 will be 0. Now left hand limit we have to find out. And left hand limit is what? When x is approaching towards the 0 from the left side. Left side closed values are less than 0. If it is less than 0, what is the suitable function? Minus x. Now limit x is approaching to 0 from the left hand side. So what is the suitable g of x? That is minus x. Now applying the limit minus 0, which is 0. Okay. Now right hand limit. Right side closed values of 0 are approximately 0, but those values are greater than 0. So if it is greater than 0, what is the suitable function? Now limit x is approaching to 0, suitable function is x. Now applying the limit is, we are getting 0. Now from this result, what we have, g of 0, left hand limit, right hand limit are equal. So at x equal to 0, g of x is continuous. Okay, so g of x is continuous at x equal to 0. Okay, next we need to prove g of x is continuous in this interval and in this interval. Okay, now let me take if x is less than 0 as a case 2. So case 2, if x is less than 0. Okay, if x is less than 0, in this particular interval we have infinite real numbers lies. Okay, so I'm going to have a common name. Let c be any real value. At the same time, c should be less than 0. Okay, now g of c, we have to check the continuity, three things are required, that is g of c, left hand limit and right hand limit of the c is required. Fine. Okay, now g of c. So what is the c condition? C is less than 0. What is the suitable function here? Minus x. So g of c will be minus c. Now left hand limit and right hand limit. Okay, here we have a 0 and some value I have taken in this particular interval c. Now close values of the c from the left side as well as the right side, both are less than 0. If it is less than 0, instead of working out left hand limit, right hand limit separately, we can find out together. Okay, now limit x is approaching to c, g of x. So what is the g of x here? X is less than 0. If it is less than 0, minus x. Now replacing g of x as a minus x. Now applying the limit minus c. Now from these results we can say that g of c equal to limit x is approaching to c, g of x. So g of x is continuous if x is less than 0. Now finally we have to check for if x is greater than 0. We need to prove it actually. Okay, now case 3. If x is greater than 0. If x is greater than 0, basically we have infinite real values lies in this interval. We are going to have a common name, that is c. Let c be the any real value. Let c be any real value. At the same time, c should be greater than 0. Okay. To check the continuity, we need three things, that is f of c, left hand limit and right hand limit is required. And f of c. What is the condition for the c here? C is greater than 0. Then what is a suitable function in the given? Here g of x we have. What is a suitable function? If x is greater than 0, we need to choose the second function, that is g of x equal to x. Then g of c will be c. Now left hand limit and for right hand limit. Left side closed values of the c and right side closed values of the c both are greater than 0. So here also same, instead of finding left hand limit, right hand limit separately, same function we have. So I am going to write it together. So limit x is approaching to c. See, if I indicate minus sign, it means for left hand limit, and plus sign, it means for right hand limit. If there is no sign, then it's a combination of the both. Okay, I am combining both. Okay, now limit x is approaching to c, g of x. So what is the g of x here? G of x is x is greater than 0. No, suitable function is x. Now replacing g of x as a x. Now limit x is approaching to c, x. Now applying the limit, the result is c. So here we have g of c equal to limit x is approaching to c, g of x. So from this what we can say? So g of x is continuous if x is greater than 0. Now totally we had t cases, right? In the case 1 we said g of x is continuous at x equal to 0. In case 2 we said g of x is continuous if x is less than 0, and in case 3 g of x is continuous if x is greater than 0. From all the cases what we can say, g of x is continuous for all the real values. Okay, g of x is continuous for all real values. Okay, so next what we need to do is, the given function is combination of two different functions. So modulus of x is continuous for all real values, just now we proved. Now h of x is what? Cos x. So cos x is a continuous for all real values, we need to prove it. Okay, so now we have h of x equal to cos x. We have h of x equal to cos x. Okay, so in real line we have infinite real numbers. So I am going to have a common name. Let c be any real value. Throughout the real line, we have only single function, so no condition like c is less than 0, greater than 0, nothing like that, no condition. Let c can be any real value, okay? And just c is any real value. To check the continuity, we need three things, that is f of c, left hand limit and right hand limit is required. Now let's find out, that is here h of x, no, that means h of c is required. So if the input is c, then outcome is cos c. Okay, now left hand limit is required. Now the left side closed values of the c are approximately c, but those values are less than c. Okay, suppose if you have number 4, okay, the closed values of the 4 are 3.99, like that, approximately 4, but one small point differencing is there, no? So that differencing, we can say, we can take it as a h here. Okay, so I'm going to replace, in place of a x, as a c minus h. Okay, now limit x is approaching to c to the h of x from the left hand side, no, h of x. Okay, here suitable function is cos x. Okay, now from the left hand side we are approaching, left side closed values are approximately c, but those values are less than c. So I'm going to make a substitution, x as a c minus h. Okay, now if x is approaching to c, okay, x is approaching to c, now in this condition I'm going to replace x as a c, so c equal to c minus h. Now taking this c to the other side, c minus c equal to minus h. Now h equal to 0 we will get, if x is approaches to c, h is approaches to 0. Now limit h is approaching to 0, cos of c minus h. Now using cos expansion formula, I'm going to expand this cos of x minus formula, cos c cos h plus sin c sin h. Now let's apply the limit now, cos c cos 0 plus sin c sin 0. Sin 0 value is 0. 0 is multiplying with the sin c, the entire term becomes 0. Then here cos 0 value is 1. With the 1, if you multiply anything the same term, then cos c. Okay, so left hand limit gives the result cos c. Now similarly we have to find out for the right hand limit, similar way. Now limit x is approaching to the c from the right side, h of x. What is the h of x here? H of x is cos x. And our right side closed values are approximately c, but those values are greater than c. So point difference will be there. So for that I'm going to take x as a c plus h. Okay, so cos c plus h. Now here x is approaching to the c, right? If x is approaching to the c, now if you apply in this condition, then c equal to c plus h, then what is the h approaches to 0? C minus c equal to h, so h equal to 0, h is approaches to 0. Okay, so limit x is approaching to 0. Sorry, h is approaches to 0. Now limit h is approaching to 0, cos of c plus h formula, using that cos of x plus y, we are going to expand this. So cos c cos h minus sin c sin h. Now let's apply the limit, cos c cos 0 minus sin c sin 0. Now cos 0 value 1, 1 into cos c itself. Now sin 0 value 0, 0 into sin c, the entire term becomes 0. So we will have only cos c. Now we can notice that h of c value, left hand limit and right hand limits are same. So from this what we can say, right hand limits all these equal. We can say that h of x is cos x. Okay, so h of x is continuous for all real values. Okay, so what are the functions we proved here as a continuous? One is g of x, other one is h of x. So let me write that. So here we have g of x is that is modulus of x. Okay, I'll write as a modulus of x is continuous for all real values. Okay, that is g of x itself, I'll write. Next we proved h of x equal to cos x is continuous for all real values. That means what we can say, g of h of x is combination of two continuous functions, also continuous, is continuous. So that means f of x equal to modulus of cos x is continuous for all real values. So that's all proof for this. Thank you for watching and please do subscribe. Thank you.